In section 3.1, we're going to be talking about frequency tables. This is going to be our first step in organizing data so that we can begin to visualize it. So for instance, we can look over here at a set of unorganized data, just some grades ranging from F's to A's. But laid out like this, it's really hard to see any patterns or anything going on here. So that's why we need to start organizing our data. And that's where frequency tables come into play. We organize this into a frequency table in order to better read and display them. So you can see how in the first column here it gives us the grade. We list out the different grades, A, B, C, D, F. And in the second column we put frequency. And frequency is going to count up the number of times we see the number of A's, B's, C's, D's, and F's. So we have like 4 A's, 7 B's, 9 C's, 3 D's, and 2 F's. And so now it's a little bit easier to see kind of what the organization is. Here we can see how many of each type of grade there is, where there's more of the letter grades and where fewer letter grades show up. So the definition here says a basic frequency table has two columns. The first column lists all the categories of data. The second column lists the frequency of each category, which is the number of data values in each category. So let's do this on our own here. It says the Rocky Mountain Beverage Company wants feedback on its new product, Coral Cola, and sets up a taste test with 20 people. Each individual is asked to rate the taste of the cola on a 5-point scale, where it says here 1 at the low end is for bad and 5 on the high end is for excellent. And so they receive these 20 ratings here below. So this is like our raw data that we want to organize. So we're going to construct a frequency table for these data. So here I've set up the start of the frequency table, and then down the first column we're going to put our taste scale numbers 1, 2, 3, 4, 5. And then we got to count up the frequency for each of those categories. So I'll look at my table of data and we'll start with the ones. We'll count up the number of ones we see here. Looks like we have 1, 2. So there's 2 ones here, that's the frequency. Then we'll look for the 2s. Looks like in here we have 1, 2, 3 2s. So put that in the column for frequency. And we'll count the number of 3s. Looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9 3s. And then for 4s, it looks like we got 1, 2, 3, 4 4s. We'll put a 4 in that column. And then finally for 5s, it looks like there are 1, 2 5s here. So put that in the column there, and that's going to complete our frequency table. Now we'll go ahead and total all these up here. If I add up 2 plus 3 plus 9 plus 4 plus 2, that gives us the total number of 20 responses that we have. Now, in some cases, we'd like to know the proportion or percentages rather than the actual numbers. For example, the percentage of students that made A, B, C, D, and F. We call these percentages the relative frequency. Another way of thinking about these things is about the sum of the frequencies. For example, how many made C or less, a C, a D, or an F? We call the sum of frequencies a cumulative frequency. And so here are the definitions. The relative frequency of any category is the fraction or percentage of the data values that fall within that category. And we calculate it by taking the frequency in the category divided by the total of all the frequencies. The cumulative frequency of any category is the number of data values in that category and all preceding categories added together. So let's go back to the taste test survey. And what we're going to do here is create the we use the frequency table that we created, but we want to create a column for the relative and the cumulative frequencies. And then we'll answer a few questions such as what percentage of the respondents gave the COLA the highest rating? What percentage gave the COLA one of the 3 lowest ratings? So now I've added a couple columns here for relative and cumulative frequencies. And we'll start with the relative frequency. So what I'll do is I'll take the total, that's the total number of responses, and I'll divide each of the frequency numbers by the total. So starting with the first one, 2 divided by 20 would give us the relative frequency. And so when I divide those as a decimal, it comes out to be 0.10. And as a percentage, that would be 10%. So another way to think about that is 10% of the respondents said the taste scale was a 1. The next one down would be a 3 divided by 20. That, when you divide as a decimal, you get 0.15, or as a percentage, that would be 15%. Then the next one, we have 9. We divide that by 20. Decimal, that would be 0.45. Percentage, 45%. For 4 divided by 20. As a decimal, that's 0.20, or 20%. And then 2 divided by 20 again is about 0.10, or 10%. Now if I add up all the relative frequencies together, it should come out to be 1, or basically 100%. Now in the last column for cumulative frequency, what we do is we take the frequencies and add them together as we go down each of the rows. So in the first one, it's just a 2. That's our first frequency. But in the next one down, we take the 2, we add to that the 3 from the next row. So that would be equal to 5. And then the next one down, we add in the 9. So it would be 2 plus 3 plus 9. That would give us 14. And then the next one down, we add in a 4. So it would look like plus 4 again, so that would give us an 18. And then finally, we add together the last number, and that adds together all the frequencies again to add up to be 20. So we're just going down the frequencies and adding them up one at a time till we get down to the full total of 20. And that's what we call a cumulative frequency. Now to wrap up the rest of this example, it says, what percentage of respondents gave COLA the highest rating? So if we want to know how many gave COLA the highest rating, we can look at the relative frequency and see that 10% gave it the highest level of 5. And if we want to know the percentage that gave it the lowest rating, easy enough, we can look at the same information. We can look at the relative frequency to see that 10% gave it also in the same way the lowest rating. The last few examples have been dealing actually with strictly qualitative data rather than quantitative data. We were doing frequency counts for things like taste tests, scores, and letter grades. And those are what we've called ordinal qualitative data. But we can also do frequency tables for quantitative data. But to do that, it's useful to group, or so-called bin, the data into categories that cover a range of possible values. So this is how we create a frequency table for quantitative data that doesn't necessarily naturally have a category. We make categories by creating bins. And so, for example, a table of income levels could be broken down into bins or categories with ranges like 0 to $19,999, $20,000 to $39,999, $40,000 to $500 or $59,999, and so on. So we're making a range of values so that we can count up the number of, in this case, income levels that fall within these different ranges. So here we're going to do that. It says consider the following set of 20 scores from a 100-point exam. What we're going to do is determine appropriate bins and make a frequency table. Include columns for relative and cumulative frequency and interpret the cumulative frequency in this case. So how we're going to do this is we're going to make 5-point bins is what we're going to call it, which means that the range of numbers will be 5 at a time. So from 95 to 99, if we go through the list of values and count up the number that fall between these two, there's actually only one that does, and that's the 98. So there's only one of those. And then our next bin would be 90 to 94. And if we look in the values, we'll see that there's two of those. Let's see, the 94 falls between those. Also this 91. So that's where we get two of those within that bin. Next one would be 85 to 89. And there's three of those. The 88, another 88, and an 86. Those all fall between those values and are in that bin. Then we have another one, 80 to 84. And we see there are three of those in here. There's an 80, there's an 81, and there's an 84. So we put those into that bin. And then another bin we're going to have is 75 to 79. And so we look around at the different values we have here. Looks like we have 76, 76, 75, 75, 79, and a 77 here as well, and a 78. All those are going to fall within the bin 75 to 79. So there's a total of 7 of those. And then lastly, we see there are 4 numbers that fall between 70 to 74. So we'll just count those up, and that's the number that'll be within that category or bin. Okay, so I've laid out a table here to get started. So we got to list out the bins that we have here. The 95 to 99, the frequency we have for that is 1. And then we have a 90 to 94, and the number we have in that bin is 2. And then 85 to 89, the number we have in that bin is 3. And then 80 to 84, the number we have in that bin is 3. And then 75 to 79, we had 7 of those. And then 70 to 74, and there was a total of 4 of those. And then the cumulative frequencies would go 1, and then 1 plus 2 to give us 3. And 1 plus 2 plus 3 to give us 6. 1 plus 2 plus 3 plus 3 to give us 9. 1 plus 2 plus 3 plus 3, and then add another 7 on the end, 16. And then finally, we'll add in the last number, get a 4, which should add up now to give us 20. Those are all our cumulative frequencies for our table. And it should agree with the total number of frequency here added up to be 20. And that should agree if I added up all the numbers in the frequency column to get up to 20. So if we want to interpret what some of the information we're getting from this table, for instance, the cumulative frequency of 3 basically tells us 3 temperatures that are 90 up to 95. And we can go down to the next one, and that would be 6 temperatures that range from 85 up to 99. And we can just kind of go down the table, recognizing that the cumulative frequency adds together all the frequencies from the bins up above it as well. Now for the relative frequencies here, let's go down and create that column. So I'll take the total. There's a total of 20 different frequencies here, count of all the different temperatures. So in the first row, we have a frequency of 1. We divide that by 20. And as a decimal, that would be 0.05, or that would be 5%. The next one is 2, so 2 divided by 20, that'd be 0.10, or 10%. And then 3 divided by 20 is 0.15, or 15%. Another 3 divided by 20, 0.15, or 15%. And then next one would be 7 divided by 20. That comes to be 0.35, or 35%. And so finally down in the last row, we have 4. 4 divided by 20, that gives us 0.20, or 20%. Now, one thing about bins that we can do is we can adjust the size of these bins if we want to. 5-point bins is working here because we don't have too much data, so we can fit it within the number of categories we have here. But in some cases, we want to make these bins bigger or smaller to fit more numbers inside of there. And if the counts get too big, we can also adjust them accordingly. So in this example, it says, consider the following frequency table for the number of children in American families. We're going to answer some of the questions regarding this information we see here. The first one says, according to the data, how many families are there in America? So what we can do here is we can take, notice the first column is number of children, and then the second column is the number of families. So what I'll do is I'll just add up everything in the second column, and that'll give me the total number of families. Okay, so when we add all those together, we come out with 70.24. And so we'll understand that that's the total number of families in millions. Now the next question says, how many families have 2 or fewer children? Well, looking at the table, the way we determine that 2 or fewer is we need to add up everything in the first column from 0 to 2. So the 13.28, the 14.32, and the 35.54. So when I add those together here, I come out with 63.14 million. Now the next question says, what percentage of American families have no children? Okay, so we can look at the number that have no children. We want to figure out what percentage that is. So the way we're going to do that here is I'm going to take the number with no children, and I'm going to divide that by the total number of families. So it's basically going to do a relative frequency for that first row for the number of children being 0. So it's going to be 35.54 divided by the total number of families, 70.24. When we do that, it comes out with 0.506 when rounded off to the nearest tenth. Or, as a percentage, that would be 50.6%. And then the next one says, what percentage have 3 or more children? Okay, now to do this one, what we're going to do is take 3 or more, so we need to take the column for 3 and then 4 or more and put those together. So what I'm going to do is I'm going to take the amount for 3 children, 5.13, plus the amount for 4 or more, 1.97. I'm going to add those together and then divide that by the total number of families. So that's going to come out with 7.1 divided by 70.25. And when we get that as a decimal, it comes out to be 0.101 when rounded off. Or as a percentage, that would be 10.1%.